Hi, welcome to Virtual CV1A. This is Miss Rena and this is Week 1, Lecture 1 of Mathematics Investigation and Modeling. Today, we will have a review of functions. Let's start with the learning objectives. At the end of this week, we should be able to review the concept of functions and determine the domain and range of a given function. So let's start. A function is a relation from a set of inputs to a set of possible outputs, where each input is related to exactly one output. Think of the following illustrations below. We have the set of input for x on the first column, the function rule in the middle, and the output on the last. What can you see in the picture here? Okay, we have a tired Barbie. She wants to look pretty again. So what do you think should she do? Okay, she should have a makeover. And the result? Of course, a prettier Barbie. Now let's go to the second picture. We have a Barbie who wants to try something new. She wants her hair to be smoother with no frizz. What treatment should she have? Okay, a ribbon hair treatment will do. And the result, of course, a frizz-free hair for Barbie. And now let's go to the last picture. We have a Barbie who wants to lose more weight instantly. Take note, instantly. She doesn't want to put effort through workout and proper diet. So what is the easiest option? Alright. She could have a liposuction. And after the liposuction, the result will be, of course, a lighter Barbie. Now let's talk about functions again. A function can be thought of as a process that takes an input variable and transforms it through a certain process into a particular output. The set of all input x is called the domain of the function, while the set of all output f of x is the range. In the illustration earlier, the dolls before they underwent a makeover are the values x in the domain. And the makeover process is the rule or equation. And the result are, of course, the values y or f of x in the range. Now let's talk about the function notation. This is how we represent functions. A function is often denoted by a letter in the English alphabet or sometimes Greek letters. Common examples are f, g, h, alpha, and beta. Let's say f is a function and x is a value in the domain. Then, for every value x, the function f will assign exactly one value denoted by f of x. Sorry for the misspelled word, it should be 1. The notation f of x is read as f of x. Also, the variable y can be used in place of f of x for that is, y is equal to f of x. Now that we are already familiar with the definition of functions, domain, and range, let's look at the following examples of arrow diagrams below and determine which ones are functions. If it is a function, determine the elements in the domain and range. Let's start with example number 1. Notice that every input x, 1, 2, 4, 8, maps to exactly one output. 1 is mapped to 3, 2 is mapped to 4, 4 is mapped to 6, and 8 is mapped to 10. Therefore, this is a function. For the solution, since the input x maps to exactly one output, this is a function. For the elements in the domain, we have 1, 2, 4, 8, and for the range, we have 3, 4, 6, and 10. Let's move forward to example number 2. For this example, 1 is mapped to 3, 2 is mapped to 3, 4 is mapped to 6, and 8 is mapped to 10. Though 1 and 2 are mapped to the same element, that is 3, the arrow diagram still satisfies the definition of a function, wherein the input x must be mapped to only one element in the range. Although they are sharing the same element in y or f of x, still they are mapped to exactly one element in the range. So this will still qualify as a function. For the set of domain, for the domain, we have 1, 2, 4, and 8. And for the range, we have 3, 6, and 10. I hope that was clear because this is the last example. We have example number 3. 1 is mapped to 3, and 1 is mapped to 4 as well. 4 is mapped to 6, and 8 is mapped to 10. For this one, since one of the elements in the set of input, that is 1, is mapped to more than one element in the set of f of x or the set of output, that is 3 and 4, then this will not qualify as a function. For the solution, since one of the input x, that is 1, maps to more than one output, which are 3 and 4, this is not a function. Let's also have a quick review of relations. In mathematics, a relation is an association between the input and the output. There are 3 types of relations. First, we have one-to-one relation. Each element in the set of input is mapped to one element in the set of outputs. This relation is exhibited in example number 1 above. This type of relation is, of course, a function. You can go back to example 1 so that you can understand this definition better. For the next type of relation, we have many-to-one relation. More than one element in the set of input are mapped to one element in the set of outputs. This relation is exhibited in example number 2 earlier. Again, you can rewind so that you can see example number 2 and relate it to this definition. This type of relation is a function. Now, let's go to the last type of relation. We have one-to-many relation. One or more elements in the set of input are mapped to more than one element in the set of outputs. This relation is exhibited in example number 3 earlier. This type of relation is not a function, and we call this a mere relation. Okay? So that will be the end of our discussion for today. I hope that you were able to recall the definition and concept of functions. Please check our Google Classroom for more updates, and I will be posting the link for our next video discussion. Thank you very much for listening, and bye!